One type of function you're going to have to be able to take the derivative of that isn't covered by the power rule, product rule, quotient rule is differentiating exponential functions. So exponential functions are functions that the base is going to be a constant and your exponent is going to have your variable. So the most simple derivative for an exponential function is the derivative of e to the x. A function you're going to see many times, and e to the x has the property of being the only function whose derivative is in fact itself. The derivative of e to the x is just e to the x. Now you might be thinking, well, maybe that's true for all exponential functions, and it kind of is. There's a little bit of a twist though. So say we had the function instead any a to the x, where a is going to represent any constant. Well, the derivative of a to the x is going to be a to the x, but you have to multiply by the ln of a. So you can see here for the special case that a is the number e, when you do e to the x times ln e is 1, and that's why that drops out, and the derivative of e to the x is just e to the x. But for example, if we were doing the derivative of 5 to the x, you would need to do 5 to the x times ln 5, and that would be your derivative. Now keep in mind, any of these differentiation methods can be combined with the chain rule. So I'll do one example of that quickly for the exponential functions. Imagine you have the function e to the x squared. So what you need to do first is, what is the outermost function? The outermost function is taking the exponential, e to some power. The derivative of e to any power is always itself. But our inner function, the x squared, you have to multiply by that derivative because of the chain rule. The derivative of x squared is 2x. So our derivative here would be e to the x squared times 2x. And that's how you differentiate exponential functions.